Okay, I welcome you all to the lecture. This is the second part of the applied networking lecture. We want to look at how we're going to log into the router, to configure the router, and then to troubleshoot the network. That is what we are learning on this second part. So I welcome you all to the lecture. Okay, if you can hear me, type yes in response. You can type yes in response at the chat. Okay, I can see some few of you are here. So we are starting right away. We want to talk about a router. A router is a device that connects networks. So to actually set up a router, you need to connect the router to a system whereby you can access what is on it. And when you connect it up like that, you need to log in into the router. You open a browser and then enter the default IP address of the router. When you do that, an interface will come up that will show you the default username and password of the router. Then you need to change the default username and password. So you change the default username to your own username, the name you want to be using to log in to the router, and also the password. You change the password to your own. That's a default that was set there before, but you will log in, you will change it to your own that you are going to be using to log in into the router. Now, when you log in, you change the password, then you log in with the new password that you just changed. Then you will set up what we call the DHCP address range. You go to that section and set up the DHCP address range. That is the IP addresses, the range of IP addresses that the router will be able to monitor. Outside the range that you must have given, any device that has IP address outside that range will not be able to connect to the network. So how do? You type in a command to actually erase all the IP addresses that might have been stored on the router. With that, you wipe out all the IP addresses, and that is called IP renew the IP. So you type in ipconfig/release, ipconfig/release. That means you want to clean all the IP addresses that might have been stored on the router. ipconfig, ipconfig/release. When you do that, all the IP that must have been stored will be erased. Then you now type another command to enter new IP address range. That is ipconfig/renew, ipconfig/renew. That will help you to change the default IP address and log in with a new IP address. Then the wireless settings, you see the wireless settings in the router, you view it, you see the default that has been stored there, then you change the network mode, then you configure the SSID, configure the channel, the security mode, then you configure the passphrase on the router. You see the different section on the router, on the interface, the user interface of the router. So as you go one by one, you go from this step one by one. Wireless LAN default, WLAN default, network mode, SSID, the channel configuration, configuration of the security mode, and then passphrase configuration. Then you can also configure a mesh network on the router, a mesh network, a wireless mesh network. Wireless mesh network will enable the router to beam out wireless signal to mobile devices that can connect in form of mesh to the wireless router. So you have to configure that one also. If you want this function to be enabled, you configure that also on the router. Then next, you configure what we call NAT for IPv4. NAT is network address translation. Network address translation that converts private IPv4 address to internet routable public IPv4 addresses. So that one is also configured. Network address translation. That is what will be converting the private IPv4 address to internet routable public IPv4 addresses. So the IP address that we normally use is private in a local area network. But before the network can be connected to the external world through the internet, the IP address must be converted to public IP address. So NAT is the part of the router that does that, converts the private IPv4 address to public IPv4 address. Okay, all right. So next after that, we look at quality of service, QoS. Quality of service allows prioritization of service for specific traffic types. So when this is set up, it will allow only some specific traffic to move on the network. The one that are not allowed will not be able to connect on the network. That is quality of service configuration. So when you configure that, you choose the network traffic types that you want to be allowed on the network, then you click apply and save it onto the router. Now all this can be practiced using your packet tracer. Packet tracer is a simulation software that you can use to learn most of the things that we are learning right here. So it's a resource in your student account. When you log in, you can go to resources and download what we call Packet Tracer. It's a software that you will install onto your system, onto your laptop, and then you can use it to practice how to do these configurations on the router. All right. So you can use that one to learn more and then watch videos also on your module when you log on. Watch the videos in the module to enhance your understanding. There's a video that explains DMZ configuration in LAN, then wireless rules. Also, we have UPnP, that is Universal Plug and Play. This is a system that allows devices that can connect to the network dynamically through wireless without anybody doing anything to them. Once you turn on the wireless access, the device will be able to link up to the network via the wireless signal from the router. But this is a wireless access, the device will be able to link up to the network via the wireless signal from the router. But this is a non-secure setup. It is not secured, so every device can just connect just like that. So that is why it is not advisable to use a UPnP because it is not secured. We have a firewall settings that can be set up on the network. We have what we call DMZ. DMZ is a demilitarized zone. Demilitarized zone, that is a portion of the network that secures or provides services to untrusted network. So a DMZ contains servers, often contains servers, and then router supports the creation of a DMZ. So we create DMZ so that can supply services to some untrusted network. So when you log on to your router and you want this to be enabled, you go to the DMZ and set it up. You can set it up so that there could be access for untrusted traffic. Then we have what we call port forwarding. Port forwarding allows traffic to be passed to specific ports. traffic will be passed to certain specific ports on the network. Then we also have what is called port triggering that allows only temporary opening of the firewall to allow data to be passed by specific inbound ports or a port range for an application or game, a port range. So that one is just for a limited time, temporary opening of firewall. Because firewall is meant to block you know, unauthorized traffic on the network. But when you use a port forwarding, it allows the firewall to pass this certain data, certain traffic on a temporary basis. So that is a port forwarding. We now have a MAC address filtering also. We can do MAC address filtering on our router. And what that means is that it is only the MAC addresses that have been registered onto the router, that have been saved onto the router, that will be able to use the network. If the MAC address has not been installed on the network, then the device will not be able to connect to the network, even though all the functionality of the device is working fine, but it will not be able to connect because MAC address filtering is kind of security. If you don't want other people that don't have that are not authorized to connect to your network, all those that you want to be connected to the network, you bring their devices and copy their MAC addresses and save it onto the router on the network. For instance, if you want to connect Wi-Fi in this school, they will register your device, maybe your phone or your laptop. They will register it. They will ask you to submit the MAC address of your device. When you do that, they will take it to the network to register you. It is the device that you register that you will be able to use on the network. If you're having a laptop and a phone and you register only your phone, even though you have username and password, you'll not be able to log in on your laptop because the MAC address of your laptop is not stored on the network. That is MAC address filtering. It is able to allow only registered MAC address of devices to connect to a network. And then don't forget, MAC address is like your fingerprint of digits, which is unique for every device in the whole world. If, for instance, you have 100 billion devices, telephone, tabs, laptops, desktops, and so on and so forth, all of them have a unique MAC address that identify each device. So MAC address filtering is used in such a way that all the devices you want to connect to this particular network, you will collect their MAC addresses and store it onto the router. After that, any other device that tries to communicate will be blocked. The router will not allow you to go and connect. We also have whitelisting and blacklisting. They are also security features. Whitelisting is whitelisting is a way to allow users, you know, to be able to connect. Those that you have whitelisted will be able to communicate to the network. And then when you blacklist some, you make sure that they cannot connect to the network. So whitelisting can be used to allow users, maybe children, or employees in a particular organization to specific IP addresses. IP addresses that you allow will be, open to people to access. Those that have been blocked, that have been blacklisted cannot be accessed. For instance, if you don't want people in your network, your wireless network, for instance, to go to a particular website, maybe, let's say, for example, you don't want people to visit Iroko TV or visit facebook.com. The IP addresses of these two websites will be saved onto the router under blacklisting. So when people want to go to that website, the router will ensure that they cannot reach there because the IP address has been blacklisted. It's only those that are whitelisted that will be open for people to access. That's another security feature on the router that can be set up or configured. Then we can learn more about MAC address filtering, DMZ, port forwarding, using our packet tracer. You can use that one to learn more. So for those of you that have laptops, I encourage you to download the packet tracer and then you install. Then we can use it to demonstrate, to learn more. You can use it to learn more how to practice some of these things. You can use it to configure firewalls. Instead of you doing it normally on a real network, system that you can actually demonstrate what you have learned on it. All right. Then we talk about Internet of Things. Internet of Things can connect to a particular network, a pre-existing network somewhere, or network of its own. They can set up network for it on its connect to a particular network, a pre-existing network somewhere, or network of its own. They can set up network for it on its own or connect to existing network in a particular location. Uh, Nowadays, there is what they call a smart home, and a smart home has a IoT devices. The capability of IoT has been installed into a smart home, and then you can easily connect to the network. The IoT devices can easily connect because it's a smart home. There are some of the IoT devices that you can find in Packet Tracer. You can find so many devices that you can connect. So when you open your Packet Tracer, you see several devices, telephone, fan, battery system, house, and so on and so forth. They are all there in Packet Tracer. You can use it to learn. Okay. Now, you can use a Packet Tracer to install some of these things and configure them so that you set up a kind of a home networking system or home gateway system that can use motion sensor, can do tests, can do security features, set up air conditioning in the house, and so on and so forth. All these things are available under the Packet Tracer. Now, setting up a network does not always work. It does not always run perfectly. There are times when problems will arise and then the network will not function well. At that instance, we need to troubleshoot the network. We need to troubleshoot the network to find what the problem is so that we can restore, normalcy. We can restore good functionality of the network. So now we want to talk about the troubleshooting of a network, the troubleshooting process. Like we have 6 steps for troubleshooting in our computer network, whether computer hardware and maintenance and the network itself. We have 6 steps for troubleshooting. The first step is to identify the problem. Then the second one is to establish a theory of probable cause. The next one is to test the theory to determine the cause. Test the theory to determine the cause. Now, the next one is establish a plan of action to resolve the problem and implement the solution. Establish a plan of action to resolve the problem and implement the solution. After then, step number 5 is to verify full system functionality and, if applicable, to implement preventive measures. Verify full system functionality and, if applicable, implement preventive measures. Lastly, the last step is document findings, actions, and outcomes. Document findings, actions, and outcomes to troubleshoot and identify what the problem is. Here, when somebody is having problem on his network, you as the technician that want to troubleshoot will ask questions. You ask open-ended questions and close-ended questions from the people using the network. For instance, what problem laptop, tab, mobile phone, what actually is the problem that they are experiencing? Another one, what software has been installed on the device recently? Another question, what was the person doing when the problem was identified? Then what error message has been received? Also, what type of network connection is the device using? Those are open-ended questions. When you ask such questions, the person will explain things from his or her mind to let you have an idea of what is happening on the network. Then there are also close-ended questions that require like a yes or no answer. For instance, has anyone else used your device recently? That's a question. Either yes or no will be the answer. Another one, can you see any shared files or printers? That's another question, which is close-ended question. Another one, have you changed your password recently? That's another one. Next, another question can you access the internet? And another possible question is this, have there been any environmental or infrastructure changes to the network? These are some of the questions that can be asked from the user of a network to determine, what the problem on the network is, to identify the problem. What we know is that network problems can be simple problems or complex problems. So it is important to start troubleshooting from minor areas, because the problem may come either from hardware, from software, from the connectivity, you know, and then it can be a combination of these problems that results into a problem that the network cannot be accessed. So as a technician, you will develop a logical and consistent method for diagnosing a network problem by eliminating one problem at a time. How do you do that? By asking simple questions, whether open-ended questions or closed-ended questions, that will be able to help you to eliminate. To assess a problem, you may determine that you want to know how many devices are having the same problem, and then if there is a problem with one device, we have to start troubleshooting from that device. Then if the problem goes to all the devices in the network, then you have to start the troubleshooting process probably at the networking room where all the devices are connected. All right. Then the first step in troubleshooting process is to identify what the problem is, like we have said. After then, you go to how to solve the problem. Now, the second step is establish a theory of probable cause. Fine, you need to know common causes of network problems for you to be able to establish a theory. When we say theory, that is, it doesn't really mean that is what you have in mind the problem will be, or the cause of the problem will be. But you must imagine certain problems that are related to what you have in front of you. For instance, you think about loose cable connections, it's a probable thing. It's a probable, cause. Think about improperly installed network interface card, whether network interface card was not properly installed. You can think of probably the internet service provider network is down, signal strength, there could be invalid IP address, there could be DNS server issue, and then there could be DHCP server issue. So after you have discussed with the customer, you'll be able to establish all these theories. You'll be able to list down the causes that you think might be responsible for the problem at hand. Now, the next thing is to, after you have, you know, list probable causes, then you need to test each of the theory to determine the cause. And then you have to follow common steps to determine the cause. And then you have to follow common steps to determine the cause of a networking problem. For instance, check all the cables that are connected, if they are connected properly. Unseat and then reconnect cables and connectors. That is, you remove the connector, unplug it, plug it back. Reboot the computer or the network device, log in as a different user, repair or reinstall or re-enable the network connection, contact the network administrator, ping the device default gateway, access a remote web page such as http www.cisco.com. You can, access that kind of a network to test whether the network is, moving fine or not. Now, all the theories that were developed, when you begin to eliminate them one by one, if it was supposed to be cable, you plug the cable, you unplug, reboot the and so forth, you'll be able to eliminate one of those theories one at a time, one theory at a time. All right. Now, in the course of this, you may be able to identify what the problem in the network is. Be able to, actually get rid of the problem. If all these quick procedure, do not work, it means you need to actually do more. You need to do more search for you to be able to correct the problem, because you must establish what actually is the problem, the cause of the network problem that is at hand. All right. The next step is step 4. You need to establish a plan of action to resolve the problem and implement the solution. Now, in the previous step, you have carried out small checks and then the problem was not resolved. So you need to do further search. And where can you search? You can search from help desk repair logs. You can contact other technicians, discuss with them. This is a problem I'm having. Can you You can go online to manufacturer FAQ websites, FAQ, FAQ, that is frequently asked questions. You can go and check some of the problem might be listed, and then the solution might be listed there also. Technical website also you can check news groups, you can check computer manual. Technical website also you can check news groups, you can check computer manuals, device manuals, internet search, and so on. These are other areas you can look into that will help you to establish a plan of action to resolve the network problem and then implement the solution. Now, simple step, you may apply simple step thinking that the problem will be a little problem and it may not work. So you may need to actually do more, dig deeper, in order to establish what the cause of the network issue is. Then after getting the cause, you have now fixed the problem. You now move on to step number 5. Verify full system functionality and if applicable, implement preventive measures. Now you have fixed the problem. You must be sure that the network is now in order. And what will you do to ensure that is to verify full system functionality. All the things that have been done or that were being done on the network before, you have to do them now to ensure that the network can do whatever it was doing or that were being done on the network before, you have to do them now to ensure that the network can do whatever it was doing before, now, so that solving one problem will not bring another problem into the network. You can use ipconfig/all, that command of ipconfig/all to display all the IP addresses information on network adapters. Then you can use ping command to check network connectivity from one location to another. When you ping from your own device, from your own system to another IP address, then the system will be able to send a signal, go and come back and tell you whether there is a thorough passage or not. Then you must verify that the device can access authorized resources like company email servers and the internet. After fixing the problem, you must ask the user to use the device to do all this so that you are sure that everything needed to be done on the network by the device can be done. Then you can research additional command also or help ask people what you can use to actually check errors if all errors have been cleared on a system or network. All right. So that is how to verify full system functionality. Now, if you have verified that everything is working, then you must implement preventive measures. After identifying what the problem is, you will now suggest to the user, the problem came about because of so, so, so. So next time, don't do so, 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 but do this to prevent the problem from reoccurring. So, and then they will appreciate that. They will like you for that. They will trust you. And anytime they are having issue, they will quickly bring the issue to you. And you'll be able to charge them, you know, adequately because of your knowledge. But the first thing is to, earn their trust. Let them trust you. After you have fixed the problem, give them what likely brought about the problem and how to avoid it next time. Don't say if I tell them today, their system will not have problem next time, so they will not bring work to me. No, you will tell them to earn their trust. So anytime they are having issues, they will remember you, they will depend on you and bring the problem to you. The last step on the troubleshooting process is to, document findings, actions, and outcomes. Everything you have done, you must, record it into your logbook. Put it down on your recording book. All the steps you took, the solution, perhaps the parts you change to ensure that the system works, the network functions, put it down in writing. Then take the work to the customer, let them verify that everything is in order. Yes, that the thing is okay. Let them verify that. So any component you use, any repair tool, special repair tool you use, any parts you purchase to fix a problem, and then probably the total time spent to fix a problem, it must be recorded. It will help you in the future also when you're having any similar problem like that. You might have forgotten the way you solve this particular one. But if it's recorded in a logbook, then you can go and carry a logbook and revise, what you have put down there. Quickly fix such ones in the future. That's a big advantage in documenting your findings, actions, and outcomes. Then let's talk about common problems and solutions for networking. There are common problems such as network interface card, LEDs light are not lit. It's not showing that network is connected. That may be because network cable is unplugged or damaged, or the network interface card is damaged. These are possible problems. And then possible solution, you have to reconnect the cable or replace the network interface card, or probably uh, replace the network connection to the computer. Either cable or the total connection to the computer can be replaced. Another one can be, another problem which may be actually advanced, may be that a device cannot connect to a network particularly by the IP address, but not by the host name. A device a device can connect to the network by using IP address, but not by the host name. A device a device can connect to the network by using IP address, but not by the host name. So that's another possible problem. One, it may be because the host name is wrong. That may be a possible cause. Another one is incorrect DNS settings, or DNS server is not operational. So if those are the problem, for incorrect host name, re-enter the host name. And if it is a incorrect DNS setting, re-enter the IP address and the DNS server. If the DNS server is not operational, restart the DNS server from the control of the network. And another one may be that a user cannot access the FTP server. A user cannot access the FTP server. That may be because FTP is being blocked by the firewall at the router. And if that is the case, possible solution is to ensure that the ports 20 and 21 are allowed through the router's outbound firewall. On the router's firewall, you must ensure that port 20 and port 21 are allowed. That's the solution to that. Or it may be that FTP is being blocked by the Windows firewall. So you need to enable ports 20 and 21 through the Windows outbound firewall so that you will not be blocked. Also, possible problem may be the maximum number of users has been reached. And so for that reason, you need to increase the maximum number of simultaneous FTP users on the FTP server. You must increase the number of users in the configuration. There are so many problems that are possible in a network. We cannot talk about everything here, but when you log on to the module, you learn more about other different problems. Some of them are advanced problems actually, and their solutions are there. The last one we want to check is a device on one network cannot ping a device on another network. When you try to ping, it doesn't ping. It means there's a broken link between the two networks. The network cannot communicate with one another. In that case, you can use tracer to locate which and fix the broken link. The command is traceat, trace, then you add RT, TRACERT, traceat. That's a command that you send to the network. That one will be able to check all the links and tell you, okay, at also point, there's a breakage, there's no link. Checking the IP address of each devices on the network, the one that can communicate and the one that cannot communicate, it identifies it. Then internet control message protocol can also be blocked at the router. That be another reason, maybe another reason why the device cannot ping. So in that case, you can configure the router to allow ICMP echo requests and echo replies. Internet control message protocol. You configure the router to allow that. Then ICMP may be blocked at the Windows firewall also. So you have to configure the Windows firewall to allow ICMP echo requests and echo replies. That's a very advanced problem. All right. So those are some of the problems that are on the network and the possible solutions to them. So that is what we study in this second part of the advanced networking uh, lecture. So far, we have learned about how to, connect a device to a network, how to configure devices for wired and wireless network, I've explained MAC address and IP address and how to actually use MAC address and IP address. MAC address and IP addressing on network have been discussed. We have discussed also how to configure network interface card for wired and wireless network. We have discussed how to configure wireless networking in a small local area network, how to configure firewall IoT devices, and then we talk about networking and troubleshooting of problems. When you have problems on a network, how you can troubleshoot. So we have discussed that. Then we came across so many new commands, new terms and commands in this chapter, like MAC address, IPv4 address, IPv6 address, static address, dynamic address, link local address, ICMP, DHCP, NATs for IPv4, QoS, firewall, UPnP, DMZ, port forwarding, port triggering, MAC address filtering, whitelist, blacklist, IoT. These are some new commands and terms that we came across in the chapter. You should be able to explain what each of them represents because they have been discussed in this chapter. That's how we come to the end of the chapter. I hope all of you are following. Do you have any question? If you have any question, please type into the chat box. Any question? Type it into the. If you can, please, you can type your question into the chat box. All right. I can see people are telling me that they are present. That's fine. That's fine. I want to take attendance of those that are connected right now. I'm going to take the attendance so that everybody that has typed something, the name is saved. And so we can use that one as a attendance. Okay. If you have any question, you can type it into the, to the chat box. After then, we can quickly answer those questions and end the class. Okay. All right. Any question? No question. All right. Somebody says you can't hear all the lecture. No problem. You can watch it again. Very shortly, I will provide a link to the video of this lecture. Google will provide a you know recorded video for us. So that is it. There's no question. We can end this class here. I can see all of you. You are typing that you are here. I can see your name. I see all of you that are present. I've noted the names for attendance. It's very important to us because we need to encourage those of you that are attending the live lecture. We need to encourage you. So don't forget to give a like to this lecture. Don't forget to give a like. Then you can ask your question. And most importantly, you must subscribe. Subscribing also earn you some regard in the class. Don't forget that. So without any question, we are going to end it now. So I want to say bye-bye to you. Bye to all of you. So if you are seeing that, if you are hearing me, that's bye. So you can type your own bye too. Let us hear you. Okay? Right? So right now I'm ending the class until another time. Bye.